Okay, this is our Cornell notes, combining like terms. So we are solving equations and we are learning target. We're going to solve equations by combining like terms. So you guys have solved one-step equations. You know how to solve two-step equations, but we're going to continue to add to that. So if you have an equation with a lot of terms, what do? Okay, so we have to identify our like terms. So that's where we're going to start. So what is a like term? A like term is terms that have the exact same variable and exponent. So an example of that would be if I have 4x plus 3x, I can combine. When we say combine, we're meaning adding together or adding a negative, two negatives together, or two positives together. So we're not talking about multiplying and dividing, we're talking adding and subtracting. So the variable here is x. Neither one of these have exponents, so I can combine them to be 7x. So I'm combining the like terms. Now, if you have 7ab squared minus 5ab squared, again, they both have an a, they both have a b, and the exponent is 2. So since the variables and the exponents are the same, I can go ahead and combine them. So what is 7ab squared minus 5ab squared? And that would leave you with 2ab squared. Okay, so those are examples of like terms. Now, unlike terms are terms that have different variables and exponents. Okay, so for example, if you had 4x plus 3y, this expression is simplified because you cannot combine these two terms. One has an x as a variable, the other has the y. Same thing would be true if you had 7ab minus 5ab squared. They both have an a and they both have a b, but you cannot take it a step farther because the exponents are different. Okay, so there's our vocabulary, like terms and unlike terms, and we're just going to go through one example together, and then we'll work through many more in class. Okay, so let's write our example down. We're going to have 9 plus 3x minus 2 equals 3x minus 13 plus 4x. Okay, so this is what I was telling you guys about. I have an equation and I'm supposed to solve this equation. Okay, this is a long equation. There's many terms, but we can do this. Okay, so we're just going to take it step by step. I'm going to draw my line. I'm going to look at everything to the left.
So looking at this equation here, I have positive 9, and this 2 is like a negative 2. I'm going to circle those because those are like terms. They're both constants. And then I have my variable here, which I cannot combine with anything. So combining my constants, I'm going to have 9 minus 2, which is the same thing as positive 7. And then I still have my constant, which was a positive 3x, and I don't need to put the positive sign there. And that's going to equal, on the other side, when I combine, I have one constant, which is my negative 13. And then for my variables, I have positive 3x and positive 4x, and altogether that is positive 7x. Now, to move all of my variables together, I can either move all of my variables to the left-hand side, or I can move all of my variables to the right-hand side. Okay, I've got 3x's and I've got 7x's. So, if I take away 3x's from both sides, my x coefficient will remain positive, and I am going to choose to do that. So I'm zeroing out. I've got 3x's minus 3x's, zeros out. And then I have 7x's, take away 3x's equals 4x's. What I have remaining in my equation is still the 7 equals in negative 13. And now I have a beautiful little two-step equation. Add 13 to both sides to create those zero pairs and to isolate my variable. Then I have remaining is 4x equals 20, because 7 plus 13 is 20. Then I need to divide each side by my coefficient, which is positive 4. 4 divided by 4 is 1, x all by itself, and 20 divided by 4 is 5. So that concludes today's lesson about combining like terms. Remember, algebra means organized, so please make sure that you have all of your work shown as we have done in our notes today. Thank you and have a great day.